Okay, so we have our problem here of the limit of 1 on x minus 1 on sine x plus 2 as x approaches to 0. So we know straight away we have an indeterminate form of type infinity to infinity. So we can simplify that straight away right here. And then that'll eventually allow us to apply our L'Hopital's rule. And that'll get our final limit of cos x minus 1, all on x cos x outside of sine x on cos x plus 1 as x approaches 0. And don't forget that plus 2. So that allows us to use the product rule. And then there we can apply it into our second fraction. And then using the reciprocal rule, we can write our limit of 1 all on sine x on x cos x plus 1. We write that. That gives us our final value for this part. And then when that approaches our fraction of all on top, which then allows us to use our product rule again. And we know that since the limit of sine x on x cos x as x approaches 0 will give us our limit of sine x on x outside of limit of 1 on cos x as x approaches 0. And that we also know that the limit of 1 on x, 1 on cos x, sorry, as x approaches 0 will just give us 1. Plug that in. That'll give us our value so that we can then use the L'Hopital's rule for the second time. And then we're nearly there. Our final equation here. We also know that the limit of cos x as x approaches 0 will be 1. So we plug that in. We know that 1 on 1 plus 1 obviously is 1 on 2. So that's our final equation for this part. And now we only need to use it one more time, L'Hopital's rule, for the third time. So we plug that in. So we have the limit of d on dx outside of cos x minus 1, all on dx dx. That'll eventually give us our value of half outside of the limit of negative sine x plus 2 as x approaches 0. That gives us our final value of 2. There we go. Thanks for listening.